Now let's take question which is based on finding number of trailing zeros in factorial n in some other base or another base. So here is the question. It says that if 100 factorial is converted into base 35, then what will be the number of trailing zeros in it? Now this question is equivalent to finding the highest exponent of n or highest exponent of 35, which is say n here, in factorial 100. So we can see with the help of an illustration that why these two questions are similar. Let us first of all recap the process of converting any decimal number from one base to another. So say if I need to find if 96 is converted from base 10 to say in base 2 or in binary, then how many trailing zeros it will have. Now what is the process of converting from base 10 to base 2? What we do is that we take that number which is in base 10 and we keep on dividing with the base in which we want to convert it. Here we want to convert this number from decimal to binary, so we'll keep on dividing that number with 2 and we'll retain the remainder here. So it will be 2 if 96 is divided by 2. So in this case it will be 48 and it is completely divisible by 2, so the remainder in this case will be 0. Again we'll keep on dividing it by 2, so the next will be 24 and again the remainder will be 0. In third case also it will be 12, so again the remainder will be 0. In the next case it is divisible by 6, so again the remainder will be 0. In this case now it is divisible by 3. The quotient will be 3, so the remainder will be 0. Now again dividing it by 2, so the quotient will be 1 and in this case the remainder is 1. And again repeating the process, so when 2 is divided by or 1 is divided by 2, then the quotient is 0 and the remainder is 1. So this is how we do it, and later on we write the number in the reverse order. So we start from this number and we go till this. So when 96 in base 10 is converting to binary, then the number so written is 1 1, that is 1 1 followed by 5 times 0. So you can see here that when 96 is converted into base 2, then it has 5 trailing zeros. Now what is the relation of these 5 trailing zeros and the number 2 with 96? As you can see that these 5 trailing zeros which we have achieved when 2 is successively dividing 96, or I can say if 96 we do the prime factorization of 96, then we get 2 to the power 5 into 3 to the power 1. So here as you can see that the number of times to divide 96 successively is the number of exponent of 2 in 96. So this particular number gives me that if this number 96 in base 10 is converted in base say 2 here, then the number of trailing zeros will be the exponent of that base when the number is prime factor or when the number is factorized. So this is the logic which I said, which I correlated and said that this question is nothing but finding the highest power n of 35 which is contained in factorial 100, because the same process will be repeated. So if I want to convert 100 factorial in base 35, the only process is that we have to keep on dividing it by 35 and retaining the remainder. So if the remainder is 0, that means factorial 100 is completely divisible by 35, and whatever the next exponent comes, say x here, if I again divide it by 35 and if this is also divisible by 35, say y times, and gives me remainder 0. So this 0 or this remainder 0 when written in reverse order will give me the trailing zeros. So the number of zeros will depend upon the number of times 35 is successively, the number of times 35 successively can divide factorial 100. So I hope this particular illustrations gives a fair idea about why this question is similar to this question, and such question we have already solved in the previous videos. So let's solve this question and get the answer. So we know that 35 is a composite number, so we cannot directly use this particular use the method of successive division and retaining the quotient. So here what we have to do is that we have to prime factorize it. So 35 is 5 into 7. So we have to find the number of 5s in factorial 100 and number of 7s in factorial 100. And then we have to pair that how many such pairs are possible. And since we know that number of 5s will always be more than number of 7s from the logic which we have already seen in the previous video, then for such question, rather than getting for both, what we can do is that we can only find what is the number of 7s factorial 100 contains. So let's start with the process of finding number of exponent of prime number 7 in factorial 100. So we have to successively divide 100 with 7 and retain the quotient. So 7 it will be 14 times and 7 it will be 2 times again 7 it will be 0. So you have to add these things. So it will be 14 plus 2 or 16. The number of pairs 5 into 7 which we can form is 16. Hence answer for this question is 16, or there will be 16 trailing zeros when factorial 100 is converted into base 35.